G'day all, welcome to week 10 of CIV 4284, Traffic Systems. This week we're talking about human factors in traffic engineering. There's many ways to look at human factors, and we're going to look at it through a lens of fast roads and slow roads, while also talking about signage and other modes. Human factors, or ergonomics, is all about understanding the way people use the environment and things around them. We need to understand this in order to better design transport systems. While people are choosing which mode to use, they're going to think we need to understand their needs and preferences, their value judgments, and how they make decisions. And then once they're on a particular transport mode, particularly driving, we need to understand their limitations, how they interact with the transport system, and what their overall capabilities are. Here's an interesting quote from Tom Vanderbilt. Take some time to read it. I remember that in evolutionary terms, we haven't been able to travel at any great speed for anything other than the last couple of hundred years. So we are built to travel. Our sensory systems are capable of coping with about 24 kilometres per hour. But above that, we don't have the evolutionary. Even taking something simple like how many images our eyes process in each second, which I think is about 16, that's many fewer than a bird that's chasing a mouse in a field. They're processing up around 60 images per second. So just from that one perspective, you can see how our evolutionary skills are not quite up to scratch with moving at very high speed. So let's look at human factors and high-speed roads. Key issues in transport system design: providing people with a dynamic envelope to move within that is safe, giving them sufficient time to react, and designing the system to make information that they need to process easy. Reaction time is the time that a driver takes to perceive and react to certain stimulus and take appropriate action or start taking that action. It's also called perception reaction time when you include the perception time. It's made up of four components. So we've got the perception, the identification that there is a stimulus we need to consider, decision making, whether or not I'm going to consider that EI light, and the volition, which is actually processing and doing something about it. There's a large variation of around 2.5 seconds caused by a range of factors. You need to make sure you understand those factors. Combine the chosen perception reaction time with manoeuvring time and travel speed, and then you can calculate sight distances and impact zones that are going to occur along any particular stretch of road. There's also a 6-second rule, which is a sort of general rule that it's going to take 6 seconds to notice something new and do something about it. So let's break down that reaction time a little bit. We start with that first sort of perception and sensation that there is something that I might need to consider, a flashing light or a red sign. And these are visual, sometimes they're auditory, it could be tactile, even smelling things, or you might feel something different with the car. Most of the information is going to be visual. The amount that we can actually sense depends on our field of vision, the number of eye movements we make per second, and the number of images we process through our brain each second. And obviously travel speed is going to have an impact on these things. So objects in the peripheral vision up to about 180 degrees can be detected, but they can't be understood. And objects in the foveal vision, 5 to 12 degrees, can be detected and understood. But the faster we're traveling, the smaller our field of vision is, because we're looking so far ahead, because that's where we're going to be in a very few seconds' time. And you can see that image difference between 20 kilometres an hour and 55 kilometres an hour. So when we're looking at sensation and perception, it's important to understand the differences that you might see something, but you don't actually take it in. So check this out.
This is an awareness test. How many passes does the team in white make? The answer is 13. But did you see the moonwalking bear?
So this is an ad from Transport for London to help people understand that it's difficult to see cyclists. So now a quick test. I'm going to flash something on the screen. Tell me what you see. The point here is that I can barely remember what I saw and I put the presentation together. You should have recognised that it's a street scene, and you should recognise some of the elements in that street scene. But where should you be and who's got priority on this particular street? You may have picked up that there's a bicycle lane on the left that is tapering to an end, and it looks like you're actually on a bicycle. There's cars coming towards you in the other direction, and the road is about to diverge into two separate carriageways. Perception is heavily influenced by expectations and the attentional resources that we've got. These attention span limits the amount of things we can comprehend. So we're going to cover this in a few sections about continuation expectancy, event expectancy, and temporal expectancy. Continuation expectancy is the idea that things that have happened in the past will continue to happen in the same way. So much like you're following a truck on a freeway because it hasn't slowed down, it hasn't put its brake lights on. Event expectancy is the idea that things that you haven't seen happen before won't happen to you. So that will never happen to me type scenario means that we get complacent when thinking about those things. Temporal expectancy is the idea that the longer a particular state exists, the more likelihood there'll be a change. So we start changing our behaviour to beat the yellow light. We need to be aware of driver expectations when we're putting in new traffic treatments, because those expectations that have historical legacies might impact on how drivers and road users perceive the space and use the space. So how does this all feed into what is essentially a driving task, or even a pedestrian, cyclist, or other transport user task? We've got all these things going on in our heads, but what does it actually mean? People have a one-tracked mind. It operates sequentially under load. There's a gate that lets information inputs through one at a time, and the rate of information processing is about 2 decisions per second. And errors occur if we exceed that rate. So we can imagine this on a graph. We've got perfect performance, and as input increases, we start to get stressed, even subconsciously, and our performance declines. And this is what happens in high-performance sports. Task shedding occurs when the demand is too high, and we start to shut down various parts of our mind. The mind does it automatically in order to process what it believes is the most important stimuli. So a major task of road design is to make the decision-making easier for all road users, remembering the most important stimuli might be the kids in the back that are fighting in the back of the car. So we need to make sure that things are as easy as possible to deal with.